Hey, this is Mr. Kingsbury, and today I want to talk to you about something called matrices. So I got my paper all set up here. Feel free to fill yours out like mine if you like. Make sure you include the date and the period. You can probably put whoever your teacher is, or put your name there. It's probably even better, I bet. This is Algebra 2. The unit is Systems of Equations, and we're talking about matrices. Our essential question is, how do I solve a system of equations using matrices? Well, let's jump right into this, and I'll try and make it as quick as possible. Before we can talk about how to solve with them, we have to understand what a matrix is. So a matrix is a system of rows and columns, COLUMNS. I believe I said that, spelled that correctly. A system of rows and columns used to organize data. Usually the data is, well, it could come from anywhere, really. So you have something, like, say, let's do this. This is 1, 3, 5, 7, 9, 2, 4, 6, 8. This is just a real simple matrix, right? Something like this, all right? Rows go back and forth, columns go up and down. So there's 1, 2 rows, and there's 1, 2, 3, 4, 5 columns. So we would say this is a 2 by 5 matrix. That's how we describe them. In words, we would say 2 by 5, like that. Okay. Also, just a quick note, the singular is matrix, and the plural is matrices, like that. Now, honestly, there's a lot of stuff that you can do with matrices that we're not going to touch. You can add them, subtract them, multiply them, divide them. You can multiply them by a scalar, which means you multiply them by all of them by the same thing. There's a lot of things you can do. And in fact, there's more than one way to use them to solve a system. But we're going to use the fastest way, the easiest way, and it's something called an augmented matrix. So what I need to do is show you how to set up the augmented matrix from a system. And then once you have that, I actually have a matrix calculator that you can use to do the actual heavy lifting, which is kind of neat. So let me just give you an example here. Let's say I give you the system 5x plus 10y plus 12z equals 310. And the next equation will be 5x plus 5y plus 4z equals 155. And then lastly, 4x plus 2y plus 3z equals 92. So this is our system, and it looks a little daunting, I know, but I promise you it'll be okay. What we're going to do is set up the augmented matrix from this, which is a lot easier than you think, and then I'm going to show you how to put it in the calculator. I do want to point out several things. First of all, I didn't use any negative signs or subtractions this time around because I wanted to keep the first one relatively simple. We will add in some things that make you have to be a little more observant as you're writing these augmented matrices and solving using matrices. We'll add those in the next couple of examples. But for now, I just wanted to keep it simple with all positive numbers. The next thing I want to point out is I have listed all of the x's in a column, all of the y's in a column, all of the z's in a column, and all of the constants in a column. That is crucial. Everything that is the same type of term must be in a column, and everything that is in the same equation must be in the same row. If you start mixing things up, you will get the wrong answer. So how do I write the augmented matrix? It's actually a lot easier than you think. Augmented matrix is spelled like this: AUG, aug, MEN, men, TED, augmented matrix. And this is going to have, it will have 3 columns, I promise you. I'm not going to fill in the back. This is literally copying the numbers from the system. That's it. So you see how it says 5, 10, 12, and 310? I'm just going to copy those. 5, 10, 12, and 310. Literally just copying them. Now, notice that this is my X column, my Y, my Z, and my constant. I've got to make sure to make that the same all the way down. So this next one, I got 5 X's. There's my X column, 5 Y's, 4 Z's, and then 155 for my constant. And the last one is 4, 2, 3, and 92. And then I'll put the other bracket on. By the way, these are brackets on either end there. They tell us where the matrix stops and starts. Starts, stops. This is my augmented matrix. Pretty cool, huh? Now comes the fun part. And we will give you a link to this in the material that you are given. But what I'm about to show you is called a matrix calculator. Okay, it looks like this. This is the one we're going to have you use because it's pretty straightforward and easy to use, I think. I'm going to zoom in just a little so you can see. Over here we have the number of rows. Over here we have the number of columns. So let's check this out. Number of rows would be 1, 2, 3. So I'm going to put 3 in here. 3 rows. And how many columns? 1, 2, 3, 4 columns. 4 columns. And then it says submit. So you'll click submit. And again, we'll give you the link for this so you can have it on your computer. Do not try and do it on your phone. If you have a smartphone, it won't work, I promise. Then we're going to copy everything from the augmented matrix we wrote in our notes here onto here. So let's do the first column, right? We got 5. Uh-oh, I clicked go, and I should not have. That was not good. 5, 5, and 4. Next column, 10, 5, and 2. And you can put them in rows. I don't care. It doesn't matter which way. Just as long as when you're done, what you have typed on the computer is what is typed or is what is written on your paper. So what's the next one we got here? 12, 4. Whoops. That is an R. That is not a 4. And 3. And then the last column, we have 310, 155, and 92. Cool. So you can see, hopefully you can see. Let me zoom out. Maybe that will help. That my 2 matrices are identical. Now I'm going to focus on here. So now that I've typed it all in, I'm going to hit submit. And it's going to, let's see. Wow. Usually when I do this, it goes right to reduced row echelon form, which is what we want right here. So I'm going to hit that button, and there we go. That's what it should give you. When I've done this on the computer, it just automatically goes to this. So I'm not sure why it didn't do that. But that's what you're going to want to go to, is something called reduced row echelon form. In fact, let's write that down really quick. Reduced row echelon, ECHELON form. Now, there's actually a long process of multiplying rows by things, adding things to things, and so forth that gets you here. And in fact, if you're interested in all the steps, here are all the steps. I am not interested in you writing any of those down, nor are the Algebra 2 teachers here. We just want you to go to the very last one, which is here, the last one on the right here. Please note that this will always be the same, 1, 0, 0, 0, 1, 0, 0, 0, 1. Yeah, what you've essentially done is reduced every row down until, I mean, there's a longer way to explain it, but basically the calculator has worked all this stuff down to what we call reduced row echelon form, and you've gotten rid of all the extra variables in each equation is really what it comes down to. So this will be X, this will be Y, this will be Z. See, the column that the 1 is in, that's the variable it represents. So reduced row echelon form looks like this. I'm going to put it on my paper. I'm going to copy it here, right? So we've got 1, 0, 0, 8, 0, 1, 0, 15, and 0, 0, 1, 10. Cool. Honestly, we don't really have the time to teach you how to do all of the steps that are in between. We want you to be able to type this in the calculator, the matrix calculator, and get this out. And here's the cool part. These are your answers, okay? Remember how originally it went X, then Y, then Z? Well, that's how the column works. Your X is 8, your Y is 15, and your Z is 10. So you would write X, Y, Z equals 8, 15, 10, and you're done. There's not a whole lot of math that you actually have to do in your head because we're giving you the calculator to do that work for you. So I've got another couple of examples that I would like to show you. I realize that we're starting to drag on here, so I will try and make it quick. I promise they'll go pretty swiftly, but I want to show them to you so you can understand some situations that pop up, all right? So example number 2. Here we go. Example 2. I'm going to give you the system 5x minus 6y plus 2z equals 21. 2x plus 3y minus 3z equals a negative 9. And then we've got negative 3x plus 9y minus 4z equals negative 24. So the augmented matrix will look like this. 5, negative 6, 2, and 21. Now I realize this says minus 6, but please remember that subtraction signs are both verbs and adjectives. So not only is it telling us that we're subtracting, but it is also telling us that this 6 is negative. So when we write the augmented matrix, that negative must come along with the 6. That's one of the biggest issues people have with matrices. Pretty much your issues are going to fall into the writing the augmented matrix wrong column or the I typed it into the calculator wrong column. All right, so we've got positive 2, positive 3. This is negative 3, and negative 9. Then on the bottom row, negative 3, positive 9, negative 4, and negative 24. X, Y, Z will equal. Let's find out. So now I'm going to go back to my calculator here. I'm going to go back. Wow. I'm just going to back it up. So 1, 2, 3 rows, 1, 2, 3, 4 columns. Number of rows, 3. Number of columns, 4. Submit. So we will go. I'll do it row style this now. So we got 5. -6. Oh, that's not a negative. Is it? There we go. -6. That was -6. 2. I wish it would just give me a keypad. And 12. Next row. 2, 3, -3, and -9. Last row. -3, 9, -4, and -24. Submit. And again, I don't know if you're going to come to this or not. If you do come to this, just hit reduce row echelon form, and it will give you all of the steps. Yay! And we're not worried about all the steps. We're worried about this. Okay? Top one is my X. So I've already written X, Y, Z equals. I don't need you to write the augmented matrix. On your test, it may say, write the augmented matrix. If it does ask you to, write it down. For our purposes, we're just going to not worry about it. We did it on the last one, so we'll be okay. So I'm going to write -2, then -14 thirds, then -3, like so. And that's my answer. That's all there is to it. Most people love matrices. Now I've got one more, and this is the one that I really, really, really want to focus on. So we've got X plus Y plus Z equals 10. And then we've got 2X plus Z, and that equals 12. And -Y plus Z equals 3. Now, I threw some stuff in here that's going to throw some people off, okay? I did some things that I need you to be aware of. The first thing I did, we'll just look at this first row. Do you see how there's no numbers next to the X, Y, or Z? There's no coefficients. That doesn't mean they don't have coefficients, but people mistakenly think, oh, there's no number there, I'm going to use a 0. That is wrong. This is not 0x. If it was 0 x's, it wouldn't be there because there'd be no reason to write it. If there's a letter there, there's at least one of those variables. So I'm going to rewrite this bit by bit, and we're going to talk about some things. So this is actually 1x plus 1y plus 1z equals 10. Now let's look at the next column. I've got 2x plus z. Now at this point, I know you know that this is actually 1z, and that's awesome. What happens is people will rewrite it, and they'll put them in this same order. They'll put 2x here, which is fine, but then they'll put the 1z here. Please remember what I said on example number 1. You have to put stuff with the same letter in the same column. This is a z. This is 1z. This is the z column, so it needs to go over here. And then we have equals 12. And here's what happens. Actually, I'll put plus 1z since it's positive. People see this hole and they're like, Kingsbury, I don't like that. And you shouldn't, because you know what? You can't type a matrix into the matrix calculator without a number there. So my question would be, in this equation here, how many y's are there? To which you would reply, why, Mr. Kingsbury, there are no y's. And then I would ask you the follow-up question, what number means none or no or there aren't any? And you would reply, why, Mr. Kingsbury, 0. So you need to put that there are 0 y's here. Rewriting the matrix is going to help you tremendously. You need to make sure that all of the stuff with the same variable is in the same column, and that you put in 1s and 0s where you need to put in 1s and 0s. Now this bottom row has the same issue as this middle row. See how this says -y? I have people that will copy that right here, but this is a y, and this is the x column. This y needs to go in the y column, and since it doesn't have a coefficient explicitly written, we need to call it -1y. This is 1z. I need to put that in the Z column, and it equals 3. And we still have a hole here. We need an X. How many X's are in this equation? None. That means we put a 0 here. You have got to put those in the right place, or when you write your augmented matrix and type it in the calculator, it will be wrong. So now the augmented matrix is pretty easy. We've got 1, 2, 0, 1, 0, negative 1, 1, 1, 1, and 10, 12, and 3. And now I can type it in here. So how many rows? 3. How many columns? 4. Submit. Let's type this in. So we have, come on. Oh, I have my finger on it in a different place on the screen. 1, 1, 1, and 10. We've got 2, 0, 1, and 12. And then last row, I almost just put a smiley emoji in there. That's no good. 0, negative 1, 1, and 3. And then we will hit reduce row echelon form. And here are my answers here. They're all fractions. I know that excites you. So we have X, Y, Z equals, and let's see what our solutions are here. So we've got 11 thirds, 11 thirds, comma, 5 thirds, comma, 14 thirds. And this calculator will never, ever, ever, ever give you decimals. That's all I have to teach you about matrices. That's all you need to know. We will give you a link to find this matrix calculator if you need it, which you will need it. So we'll give you links in that particular day so you can open it up on your computer. You don't need to worry about it right now. Just make sure you have all these copied. And thanks. I'll see you in class.